Right now, we're going to do a double replacement acid-base neutralization titration, it's called. And a titration is figuring out, well, basically figuring out amount of product you're making or reactant. Um, and we'll be doing we'll be showing you a lab on doing this as well. All right, the question is how many mils of 1.1 molar, so if finding X mils of 1.1 molar sodium hydroxide, how many mils of 1.1 molar sodium hydroxide are needed to neutralize 310 mils of 0.67 phosphoric acid? And so you have a certain amount of acid here that's determined by this value right here. Okay, and what you want to do is add an acid, a base to it, okay, um, to neutralize it. Okay, so you're going to start out with something that has a low pH, maybe like a pH of, I don't know, we can figure it out. And you do that in 122 if you take it, let's say the pH is 1.2. And then after you add the appropriate amount of base, your pH will be equal to 7. Okay, so what we want to do is how many mils of this amount of base are needed to neutralize this much. Okay, so write the balanced equation and then set up the recipe table. Now you're given this. Now, for this case, you're not going to have a limiting reactant, okay, because you're only given one of the reactants. And you're also not going to find any product, so you're not going to worry about this over here. What you want to do is just find out this number here, okay? So this one's different, is that there's there's only one reactant, and you're not finding product. You're actually finding the other, how much of the other reactant you're going to use use it all up. All right, so what we're going to need is all right. We're going to find one product, just water. so we're given a reactant. We're going to solve for the other reactant and also the product. Okay, so we don't. So let's go through that. How many moles of phosphoric acid is there? So change the milliliters to liter, divide by 1,000. Change big M to moles per liter, then you get liters times moles per liter will give me moles. Okay, all right, so that's how many moles of phosphoric acid you have. Okay, so we're going to find out how many recipes, and then so we go up here, and then we're going to go at okay, step 4 we can skip because we only have one reactant. And so first step is to figure out how many recipes you can do. So you take the 0.277 moles, divide by the moles per recipe, and we'll do the reaction 0.277 times. So bring that number over here and over here as well. And we're going to bring it over here, but we're not going to need it. Okay. They figure out how many moles. So you multiply moles recipe by the number of recipes you can do. So you get. So this is how many moles of sodium hydroxide you're going to need to neutralize the acid, and this is how many moles of water you're going to produce. Okay, so step 6 is to figure out what is the amount of products, the amount of material you're going to get from the moles. Okay, so we want to find mils of sodium hydroxide. It's molarity, so we're going to be using molarity, but instead of multiply, we're going to be dividing by the molarity. So so 0.6232 moles divided by 1.1 moles per liter. It give me 0.566 liters of sodium hydroxide. And we got this number from the previous slide. And then figure it out to change to mils to multiply by 1,000. So you'll need 566 milliliters of 1.1 molar sodium hydroxide to neutralize 310 mils of 0.67 molarity phosphoric acid. Okay. And then how much water you're going to form? Okay, well, water's a liquid, so you can be using density. So first thing to do is find out how many grams it is. So you multiply the molar by the molar mass. It's 11.22, and then you divide by the density, and you get 11.22 mils of water formed. Okay, so this is a acid-base reaction. Okay, in this case, we're given one reactant, and right, and you didn't have to find limiting.